Okay, so let's take a look at these review problems and see if Eric is right. So what does the little plus mean in the limits? Do you remember? From the right. So here's from the right. Here's from the right. And here's from the right. But when you're really saying from the right, you're really saying from the right of 2 on the x-axis, right? The answer is not the x, it is the y value. So as x gets really close to 2 from the right, what y value is this getting close to? Excellent. What y value is this one getting close to? 4. And what is this one getting close to over here? It's going to positive infinity. Excellent. Okay, so we did all those right. Okay. What does the minus here mean? From the left. 2, 2, and then this from the left is going to positive infinity. When does a limit exist? Do you remember that from last year? When the key word, the left and the right have to go to the same real number, right? So, is that correct? Is that 2? Yes, the limit from the right and the left are going to the same real number. What does D and E mean? Are they going to the same real number? Okay, this answer here. That is correct, but you could also say does not exist. And why is that? Because it's not a real number. Okay. So either answer would be acceptable, to be honest. One of the things that we'll be doing is when we look at limits, we will look at them 3 different ways. We will be looking at them numerically, graphically, and algebraically. And we did all of this basic stuff in pre-calc last year, but let's kind of review how we're going to do this year. So what will happen on the homework, for instance, is they will have this limit written down, like limit x approaches 2 of x squared minus 3x plus 2 over x minus 2. Now the reason we're examining it here is because of this guy right there. What is that right there? That is the domain, right? When you have a rational function, what do you do to the denominator? Now they go to 0. Excellent. Okay, so if I wanted to know what this limit was using a calculator, I would do a chart. That's how we do it numerically. And remember we did this last year. So on the homework, they're going to give you these charts, but on a test, I may or may not. So let's just pretend I don't give you the chart. What would be some good numbers from the right of 2 to use? Okay, you're getting too close. Usually you'd start about where, though? 3 might be okay. 2.5. Now do what you tell me. 2.1 and then 2.0001, right? Or something like that. Do you have to use those exact numbers? No, you could have done 2.1, 2.01, 2.001, 2.0001, okay? The book may pick different numbers than we would. That's okay. All right, what about from the left side? Maybe 1.5, 1.9, 1.99. Yeah, that's what I'm hearing. 99999. Now, why do they have that question mark where 2 is? Yeah, it's undefined, isn't it? Since the domain is x can't be 2, if you substituted 2 in there, what would you get? An error on the calculator, right? Okay, so let's talk about then how would we do this on a calculator? Okay, so whether it's an Inspire or on the TI-84, for some of y'all are using that, you need to graph this function. So on the Inspire, what you'll do for y'all with that, we're going to, emulator up. Okay, to home, and do number 2 here, graphs and geometry. And then we're going to type that function. So since it's a fraction, we're going to do control fraction. And since I've got that page closed, somebody tell me what it was. It was like x squared 3x plus 2, and then down, and it was x minus 2. All right, for y'all doing this in the 84s, you're going to press y equals, and be sure to put parentheses around the top part and the numerator and the denominator. All right, so I'm going to do enter to graph it, and surprisingly I get a line, don't I? Okay, so let's say now I want to do the table on my calculator. All right, on the Inspire, what we do is we press menu. I haven't done this in a while, so just 1 second. Here we go. You go menu and do number 2 for view. And then down at the bottom, it has add function table. If you press enter, it puts a table over there. On your 84s, you have to do second table set and make sure you still have it on independent ask. And then you do second table, and then you can put your numbers in there. Now, just like the 84, on the Inspire, we have to tell it to do independent ask so we can have control over the table. So the way you do that is you press menu, and if you arrow over, it's got edit function table settings. So menu, and then arrow over and go to number 3. And you're going to need to press the tab button until you get here to independent. And down arrow and put it on ask just like we did on the 84. And then I can put my numbers in that I want. So I'm going to do, I think y'all said 1.5, 1.9, 1.999, 1.99999. And clearly, what are these numbers getting closer and closer to? 1. And remember, if you plug 2 in, you're going to get an error message. That's what it looks like on the Inspire. And then I think we had like 2.00001, 2.01, 2.1, 2.5, and so on. We have those kind of numbers. Now, your work is writing those numbers down in that table that they have. Now, on the homework, the table is constructed for you. So you just have to put the y values in, the function values. All right, so let me go back to where I was writing that. Let's see, there's a way to do this. Take a picture. Okay, so there's a picture of it there. So that's what we're going to end up writing. So if I were going to use these numbers then, if I was just doing this on homework, what you would do is you would say x and then say f of x like it has on the handout, and 2 in the middle, we'll put a question mark, and so I would have 2.5, I'd put 1.5, 2.1, I've got 1.1, 2.01, 1.01, and then 2.00001, we get 1 there, right? Is it really 1? No, the calculator just rounded it off to 1. It's probably going to be like 1.0000000, several ones there. Now, when I did it from this side, weren't both of these going toward 1? Sure. So what that means then, going back to the handout, if you want to fill this in, f of x is approaching 1 in both cases. So that means this limit is equal to 1 because the limit from the right is equal to the limit from the left. So since the limit from the right is equal to the limit from the left, you know the limit is 1. So that's how you do it numerically. All right. Well, what if I wanted to do this graphically? Well, using a calculator, if I wanted to do this graphically, honestly, it's harder, I think, to do it graphically because get your calculator back where you can see the graph. And I don't know about y'all, but, you know, I can kind of go to 2 right here. And I can see that, but is that graph really accurate? No. What should really be right there? A hole. And see, it doesn't show it. So I think in this instance, a graph is not really the best way to do it. I think the table is far superior if you didn't know how to do it algebraically. But the graph problems on the homework, they give you the graph, so this is not going to be an issue. But do you see where the graph does back up what you did? Because the limit from the right and the left at 2 are both going closer and closer to 1. So we kind of have that backup there. Questions about that? All right. So, basically then, our limit notation, we just said the limit is x approaches 2 of our function is equal to 1. And remember that for your limit to exist, it must be a real number. And to fill in the blank here is if f of x becomes arbitrarily close to a single number L as x approaches C from, and this needs to say the right and left side, then the limit is going to be L. So then the question becomes, and we're going to get more into this tomorrow, is when will a limit not exist? What would be some cases where a limit would not exist? Now, from the table, it's easy to see. On a table, if the numbers are different, you know it doesn't exist, right? But let's look graphically at some cases where the limit doesn't exist. So, now I'm going to kind of cheat and tell you what the graphs look like, because this is what it would appear in the book. Would you agree here that the domain, and we're skipping a couple of problems, but would you agree the domain's x can't be 3? All right, here's what this happens to look like. We'll learn later why.
Could I have your attention, please? We have messages in the office for Victor Bond, Kaylee Avant.
All right, I still have 2 more minutes. So would you agree here that this limit doesn't exist because it approaches a different number from the right and the left side? Because where is this going to from the right? Positive 1, right? And where is this going from the left side? Negative 1. So they're different, right? So if you're writing this symbolically, the limit x approaches 1 from the right is going to 1. The limit x approaches 1 from the left is going to negative 1. So that's one type of limit, a function where a limit won't exist. The other type we've already seen, this function will kind of look like this. What's going on there? Right. So what it will say is this thing either increases or decreases without bound. Okay, what does that mean? It increases or decreases without bound. What does that really mean? Yeah, it's either going to infinity or negative infinity. In other words, we have a vertical what? Asymptote. So that limit does not exist because it does not go to a real number. Now, technically, you could say this answer is positive infinity, but you also could say it does not exist. Okay, and let's look at one more and then we'll call it a day. I guess not. Okay, so we'll pick this up tomorrow. Homework sheet is on the Google group. I will try to print these out later today, but if you want to write it down, it's 1 through 17 odd on page 54. It's 1 through 17 odd. That's homework 2.